Greetings, netizens of YouTube, it's Ted again. Today I'm here to tell you about Robotech models, specifically the work of Jean F. Moscato. I'm a big fan of his work, as you can see. I bought many of his kits, and I've even built a few of them. Today, I'm here to tell you about his 1/48 scale Bioloid. I bought 3 of these kits myself at a total of $1,000.
Anta baka?
Now, I'm hardly a professional model maker, but I've had years of experience, and if you're an amateur like me, you may find this step-by-step process to be of use. So, let's get to it, shall we? The Robotech Masters portion of the series was adapted from Superdimensional Cavalry Southern Cross, a short-lived science fiction TV series from 1984. The Bioroids were alien mecha attacking a remote human colony on the planet Gloria. Despite their bulky designs, they were highly maneuverable and skilled combatants. Their hover platforms allowed them to travel at great speeds and launch aerial assaults on the sparsely populated human settlement. Later in the series, after examining a captured Bioroid, they discover the robots are actually piloted by subjugated human prisoners. Anyway, let's open the box and take a look at the contents. Inside, you'll find a beautifully constructed and painted figure. Now I can know! Just kidding. What you actually find are a couple of Ziploc bags full of hand-sculpted resin parts. It's a good idea to lay all the parts out first and confirm you have everything you're supposed to, especially if it's a ridiculously rare garage kit like this one. This 3-in-1 Bioloid was a limited run of only 30 kits, and I pre-ordered 3 myself, so I'm likely the only YouTuber in the world reviewing this kit. Like all Moscato Hobby products, the resin castings are of excellent quality, but it's still a handmade garage kit, and it's going to require a lot of specialized tools and techniques to achieve its potential as a display piece. Let's start at the bottom and work our way up. These toes are easily trimmed with a pair of nippers, but you'll need to use a metal file, or at least a nail file, to preserve the flat surfaces and straight lines. Prominent protruding surfaces like these are most likely to suffer damage to the paintwork, so it's best to give them extra attention. The heel can mostly be trimmed with a hobby knife, but will definitely require significant sanding before it's ready to paint. An old toothbrush is useful for keeping resin powder off the parts you're sanding. The base of the foot here won't actually be visible, so it only needs to be trimmed well enough to fit flush with the heel. Now here's a typical example of where resin kits require metal reinforcement. These toes could be glued in place, but they might not be able to support the weight of the figure. Wave in Japan sells brass and aluminum rods in various thicknesses for just such a purpose. The brass rods are stronger but more difficult to cut, whereas the aluminum rods are softer and can be bent by hand. First, I visualize precisely where I want the hole to be. I'll stop drilling long enough to confirm the hole is properly centered before continuing. After confirming the appropriate angle, I drill a matching hole in the foot, rotating the part as I go to make sure the angle is correct. As the rods and holes are a matching 2mm diameter, they should fit tightly together. Once the rods are installed, estimate the length you need and cut off the excess. The aluminum rods can be snapped with a pair of nippers, and once installed, they are pliable enough to allow a little fine adjustment to ensure the perfect angle. We'll secure the heel the same way. A much shorter length is required here. Thanks to metal reinforcement, the foot can now handle a lot more weight. The ball-jointed ankles are extremely well designed and fit so perfectly into their sockets that friction alone holds them in place. Most of the time, anyway. If you want to tighten up a friction joint like this, however, a quick and easy solution is to use a little instant bonding CA glue to increase surface tension. What you've got to do is slowly rotate the joint to ensure even coverage and keep the parts in motion until the glue has dried. The slower you move the part, the tighter the joint is likely to be, but don't let the glue fuse the parts together. There's a little bit of mold flash to be removed from the shin, easily taken care of, and bits need to be trimmed off the tips of the shin armor. These tips are intended for the blue or green Bioroid types, but should be cut off and replaced with different parts for the red Bioroid. Pliable sanding sponges like these are ideal for curved surfaces. You'll likely sand off some of the molded panel lines here, so it's best to rescribe them if you want them visible after painting. They may not have been intentionally sculpted as a part of the panel line detail, but I like the way they look and went out of my way to preserve them. A dedicated scribing tool would be better for this sort of work, but I'm avoiding the use of fancy tools for the sake of this tutorial. The ankle guards need a little trimming, both on the inside and outside edges, but will fit flush with only a little sanding to even out the surfaces. As with all Moscato kits, the parts are designed to fit together seamlessly for ease of construction. I primarily use CA glue with resin parts because it bonds really tightly to the material and dries very quickly. What is colloquially known as crazy glue is a type of cyanoacrylate that's cheap and readily available just about anywhere, and it's always a popular choice because of how rapidly it polymerizes. Moving on to the knees, there's only a little bit of cleanup work required, and once the ball joint is sanded smooth, it fits so well into the socket in the shin armor that the knee can hold the weight of the lower leg. See that? The knee attaches to this thigh piece a complex series of compound curves that's a little difficult to trim because of all the curved edges. Like the knee, the thigh parts vary between bioroid types, so it's best to confirm you've got the right combination of parts before painting. The outer surfaces are easy enough to level with sandpaper, but bits on the inside like this require a Dremel to properly remove. This cylindrical sanding head is an ideal circumference for the recessed top of the thigh. The Dremel is an effective tool provided you have the right attachments for the task. I'm also using 2mm aluminum rods to attach the knees to the thighs, so more holes have to be drilled in each part and carefully aligned with each other. Another advantage to the softer aluminum rods is the ability to knurl the ends with a pair of pliers. A knurled tip like this will grip the hole more tightly than a smooth surface would, and this way I can ensure the rod will always stay pinned in the thigh while I can pull it out of the knee at any time. By drilling multiple holes into the knee at different angles, I can change the position of the leg depending on the pose I want to display the bioroid in. I can have the knee bent forward, or straight leg, or at a 45-degree angle. However, since these parts will need to stand up to regular handling, they require special attention. It's clear that these areas will frequently be rubbing up against each other, so the surfaces should be roughest where the possibility of damage to the paint is highest. Paint will adhere better to a rougher surface and is less likely to chip with repeated handling. A common problem with garage kits is voids like these, where air bubbles get trapped in the silicone molds and leave holes in the cast resin parts. The best material for filling in voids like these is polyester putty, a two-part solution that requires both a hardening agent and the putty itself. For small voids like these on the fingertips, however, I find it quicker and easier to just apply a little glue and use powdered resin as filler. Just dip the ends into the powder and it bonds to the glue. Sanding resin parts smooth always generates a great deal of this powder, and I often collect it for later use. I use an old Q-tip to push the powder into the holes, and a toothbrush to clean off the excess. It dries in a matter of seconds and then can be sanded smooth. I had a number of old Revoltech joints that were just the right size to articulate the fingers, so I drilled matching holes in each finger to make fully functional hands. The fingers can be posed like a fist, or opened to grip onto the hover platform handlebar, or a pistol, or anything else your bioroid might want to grasp. While the bioroids themselves required very little modification, I felt the hover sleds needed some minor changes to ensure aiming accuracy. When examining the animation model sheets, details like the shape of these yoke shields differ significantly from the parts included in the kit, so I reshaped them to better match the line art. Likewise, this recessed engine grille on the back is a protruding detail on the model, so I measured the exact dimensions required and cut styrene beams to build a frame around the housing. Honestly, there were numerous little details to account for, the most significant of which concerned the width of these channels extending out from the front of the platform. As this is messy work, I did the dremeling and filing in the sink to allow for easier cleanup. After a little putty and sanding to ensure straight lines, the platform was looking much more anime accurate. The most difficult part, however, was getting rid of this unsightly buildup in the back corner of the platform. All three of mine had exactly the same problem, undoubtedly caused by something stuck in the mold, but it required several specific tools to cleanly remove. Eventually, I was able to resculpt the corner to match the starboard side, and after a little putty to smooth it out, I was ready to paint. Before painting, you should always scrub each part thoroughly in soapy water to remove any oil, chemicals, or mold residue. This is a very important step which is often overlooked. For spraying small parts like these, I drill small holes in the underside to attach thin rods to, so my paint clips have something to grip onto. This kit also has some rubber parts that need a special coating before they can be painted. If you try and spray over the rubber itself, the painted surface will crack and flake very easily. My solution was to apply a coating of PVA glue, known to Americans as Elmer's school glue, that dries clear over a 24-hour period. Once dry, this surface is a lot more pliable and will bend and fold without cracking the paint job. Primer is typically gray in color, but when painting gray parts, I prefer to use a darker color to provide a strong contrast between painted and unpainted surfaces. This way it's easier to confirm full coverage and spot minor imperfections in the surface after a light sanding. It's necessary to sand down the part after the first primer coat is applied, so that all protruding surfaces are rough enough to ensure a resilient coat of paint. The second coat of primer will therefore be stronger and more consistent. Each part will be painted at least 7 times, first with a few coats of primer, then a couple layers of black surfacer, then the base color, a light coat of the primary color, a flat matte clear coat after decals and panel lining, and finally a semi-gloss top coat after dry brushing or weathering is applied. Since each coat of paint should be given at least 24 hours to fully cure before the next layer is applied, each part will probably take 10 days to completely paint. For the red bioroid, I spray a light coat of maroon over the black surfacer, and then the primary red coat. The hover sled color was more difficult to achieve, however, requiring a light red coat over the surfacer, followed by an olive drab layer over the red, and finally a faint dusting of light brown to finally achieve the desired color. The heads are the most difficult to paint because of the mix of different colors and surface textures required. The domes are meant to be shiny black. On this head the surrounding frame is red, and the mouth parts are a flat pink, requiring several layers of masking. After masking off the red parts, I applied another layer using the same red in order to seal the edges and prevent subsequent colors from bleeding under the masking tape. After that, I painted the pink bits on the front and masked over them. A black layer is always needed under chrome silver to provide color consistency. And finally, a couple layers of smoke gives that glossy, transparent effect. Now, irregularly shaped parts can be very difficult to mask properly, so I make my own custom paint masks by tracing out the shapes on masking tape with a thin marker, then using a small pair of scissors to cut along the lines. Generally, the resulting pieces of masking tape will fit those irregular shapes perfectly. A good masking job can be very rewarding once the paint is properly cured, but you've got to resist the temptation to check your work before it's dry. Naturally, there will always be edges that need a little touching up. Thankfully, strong black lines separating each color fits the anime aesthetic perfectly. After a flat green base coat and a brighter primary coat, I use a thin Copic marker for panel lining these forearms. Each line takes 2 or 3 passes to get a clean, even line. The next stage is finding appropriately shaped decals to complement the natural curves in the armor. I cut out the ones I like and submerge them in water long enough to dissolve the backing adhesive, then carefully slide them onto the part and smooth them out with a Q-tip. It takes patience and an eye for symmetry to apply decals accurately. Once they're dried, you'll need to apply a clear coat to protect them from damage. A top coat should be evenly applied, spraying from all directions to ensure consistent coverage. I decided to use these ball joints from Hobby Base because they're strong and tight. So strong, in fact, that I needed tools just to force them together. And the resulting fit is stiff and reliable for ankle joints, which are key for maintaining balance, as any action figure collector will tell you. This time, I'm using strong brass rods to attach the joints to the shin armor, and drilled 3mm holes into the base of the feet to attach the pegs. The joints are stiff, strong, and secure. Once assembled, they provide a terrific range of motion. Okay, time for final assembly and photography.